Does the function satisfy the hypothesis of the mean value theorem on the given interval? So the function is natural log of 2x. The interval is 1/2 through 16. If it does, if this function satisfies the hypothesis of the mean value theorem on this interval, find all the numbers C that satisfy the conclusion of the mean value theorem. Whenever we have a natural log function, the domain is all positive numbers, okay, ln of x. At 0, ln of 0 is undefined, but anything positive. And this interval is inside here. That means this function, since this function is continuous and differentiable in its domain, and this interval, the given interval is inside the domain, yes, it does satisfy both conditions. So since f is continuous and differentiable in its domain, okay, f satisfies the hypothesis of the mean value theorem, that is mean value theorem on, in this particular on 1/2 through 16. All that means f is continuous on this interval and f is differentiable on open interval. That is, f is continuous on 1/2 16 and f is differentiable on 1/2 16. Okay, then we need to find all numbers C that satisfy the conclusion of the mean value theorem. And we know that the mean value theorem tells us the slope of the secant line is same as the slope of tangent line at some point C. To find the slope of tangent line, we find its derivative. So what is the derivative of natural log of something? When we have natural log of u, when we find its derivative, it's 1 over u times u prime. That in this case, ln of 2x is like u, 1 over 2x times derivative of 2x, which is 2. And by the way, this 2 is on the top, this on the bottom, so we can cancel. That leaves 1 over x. That's the slope of tangent line derivative. Now we need to find the slope of secant line. That is f at b of b minus f a over b minus a. Where the first point is a, this is b. Okay, this is pretty much rise over run, slope of secant line joining these 2 points. F of b means evaluate the function at 16 minus f of 1/2 all over 16 minus 1/2. Now we need to find f of 16. So let's plug in here. F of 16 is ln of 2 times 16. So ln of 32 minus f of 1/2. That means ln of 2 times 1/2. 2 times 1/2 is 1. So ln of 1 all over 16 minus 1/2 means 15 and half, which is what? 31 halves. Let's simplify. ln of 1, if you punch in your calculator, this is 0. So ln of 32 is a decimal number. I'm not gonna go into decimals because they are not exact answers. ln 32 all over 31 over 2. So if we simplify, 2 goes to the top, so 2 ln 32 all over 31, or we can write 2 over 31 ln 32. Now by the mean value theorem, the slope of tangent line is same as slope of secant line. From this we are able to determine the value of C. Then by the mean value theorem, this 1 over x should be equal to this number, 2 ln 32 over 31. Now let's isolate x. Since we have one fraction in the left, one fraction in the right, we can simply cross multiply. That makes x times this junk. Let me write in that way. X times 2 ln 32. I'm writing in this way so that I can easily isolate x. X times this equals 31. Now divide by this number. So x equals 31 over this number, whatever that is, 2 times ln of 32. And this is a decimal number which is inside this 1/2 16. Obviously you can punch in your calculator and get decimal approximation, decimal number, and you will see that will be bigger than 1/2, less than 16. Okay, so that's the C. That is the C we are looking for is 31 over 2 ln 32. Final.